Hello friends, welcome to the channel NetKingIT. In this video, we will discuss about part 2 AWS networking terminology. So it starts from number 8 till number 18. If you have missed part 1 video, then please find the link below in the description of this video. At the end of this video, I will share the high-level diagram which will help us to find all the services in one frame. So which will help us to understand the placement of these services in AWS cloud infrastructure setup. Let's start. NACL. NACL is Network Access Control List. It is act as a stateless subnet level firewall, providing a security by filtering traffic via inbound and outbound rules. NACLs protect the entire subnet boundary. By default, NACL allows all traffic. So if you see NACL here, it acts as a firewall and it is on the subnet level boundary. So in case anyone want to access any of the server from outside of this region or any VPC or somewhere from the other VPC, then it will get filtered here. So let's say some traffic is coming from outside to access one of the server. By default is allowed, but through the NACL, we can set some firewall policy to restrict the traffic on particular ports. Let's say I want to allow only port 443, then I can put one entry inbound direction where we can allow just port 443. The rest port will get blocked on the subnet level. So this policy, or we can say this NACL access control list, will allow only port 443 and rest of the ports will get blocked and it will get applied to whole subnet. Hence, whatever the servers inside this subnet, that will get access only on the 443. So rest of the ports will get blocked. Similarly, there is one more entry we need to do. By default, it is allow the access for the outside. So something, let's say any URL or any website that server need to access, then we need to put out direction rule as well to allow the traffic over the internet. So basically, NACL is filter the traffic via inbound and outbound rules. I hope you understand so far. Next, security group. Security group in AWS VPC act as virtual stateful firewalls for EC2 instances and other network attached services within a VPC, controlling inbound and outbound traffic at the instance level. Security group operates at the instance level, not the subnet level. By default, it has no inbound rules, meaning all incoming traffic is blocked by default. So initially when we check the NACL which applies on the subnet, if we don't apply any NACL, or by default NACL allows all the traffic. But security group is on the instance level. We can apply this security group on particular server level. It applies on the particular server interface. So each server has their NAC card on which we can apply this security group. So by default, there is no incoming traffic is allowed. Hence, we need to put the specific rule, specific ports we can allow with the on the specific instance. So let's find the difference between the NACL and security group. So NACL is a stateless firewall. Stateless means it required bidirectional filtering. So for NACL, we need to allow the traffic going outside. Similarly, we need to put one more entry in the NACL to allow the access inside. Hence, this is the stateless. In stateful connection in security group, once we allow the traffic, let's say coming inside to the server, then we no need to put reverse traffic rule. It will get allowed by default. So just need one rule to allow it. By default, it will send the response to that request to the internet, right? In this case. So there is no other direction rule need to place in the security group. NACL is the subnet level and the security group is at the instance level. NAT gateway. NAT gateway is a managed service that acts as a secure one-way bridge allowing servers in a private network to access the internet. So it is one-way traffic. Your servers can go out to the internet, but the internet cannot come in directly. So what does it mean? Basically, as we discussed, private subnets are not directly attached to the internet gateway. Hence, the resources inside the private subnet cannot have the internet access. If we want to provide the internet access to the private subnet resources, then we need to take a help from the NAT gateway. So NAT gateway always resides inside the public subnet. So let's take an example. One of the resource inside this private subnet want to access the internet, then it will connect to the NAT gateway, and from NAT gateway it will go to the internet gateway for the internet access. Okay, so this is a one direction. For example, we have the Windows server here, and Windows server need to download the Windows patches. Then we need to provide the NAT gateway to connect the internet gateway and download the patches from the internet. It is a one-way traffic. Your servers can go out to the internet, but the internet cannot come in directly. So there is no provision. Someone sit on the internet and try to access the private subnet resource, and this is not possible. So only from server to the internet, that one-way traffic is allowed through NAT gateway. But the reverse traffic, if someone from the internet initiate the traffic to access this resource inside the private subnet, it is not possible. Next, AWS Elastic Load Balancing. So we call it ELB. It acts as a traffic manager, automatically distributing incoming application traffic across multiple targets like EC2 instances, containers, or IP addresses. By spreading the load, it ensures high availability, fault tolerance, and prevents any single server from becoming overwhelmed. So let me show you with the example. If you see this load balancer, it resides between the two AZs. This is not part of AZ1 or the AZ2, because when the traffic, or let's say take an example, we have one URL placed on this load balancer. Any traffic coming from outside internet to this URL, after this load balancer, there will be the server farm, but it will get divided into different servers. Okay, so let's say how the load balancer provides the high availability and prevents, it provides the fault tolerance, prevents any single server farm becoming overwhelmed. So basically, take an example. If this AZ goes down, in that case, this AZ will serve the request. Okay, whatever the request coming from the internet, this load balancer shares that load between these servers. So load balancer is the traffic manager and automatically distributes the traffic among all these servers. Also provides the fault tolerance. If this AZ goes down, then it will serve from this AZ. Okay, so let's recap one more time. The orange box is nothing but the region. Inside this region, we have one VPC. We can create multiple VPCs, but for a simplicity in this diagram, I have shown you single VPC. Each VPC has CIDR network block that we divide into multiple subnets according to our requirement, and that subnet resides within data center AZ1 and AZ2. So one region contain at least 3 AZs, but for simplicity, I have shown you here 2 AZs. So load balancer resides in the VPC and it provides the high availability and fault tolerance, dividing traffic among all the servers behind it. So that servers can be the part of multiple AZs. AWS VPC peering. So AWS VPC peering is a networking connection that links two virtual private clouds together, allowing them to share data directly using private IP addresses. If you see here, these VPCs, I have added couple of more VPCs here. As I said, one region can have multiple VPCs. So in this example, we have total 3 VPCs. This is one VPC, this is second VPC, and this is the third VPC. If you see, each VPC has their dedicated separate network block. So these resources, those VPCs are isolated and separated from each other. Let's say we need to enable the communication from one of the resources from this VPC to this VPC server, then it is possible with the VPC peering. Okay, so VPC peering is the networking connection that links two virtual private clouds together. In this example, if you see, there is a VPC peering between two VPCs, but both the VPCs belongs to different region. So cross account and inter-region connectivity is possible with the VPC peering. It connects VPCs across different AWS accounts or regions. Next, AWS Transit Gateway. So it acts as a central managed cloud router connecting thousands of Amazon VPCs, AWS accounts, and on-premises networks through a simplified hub and spoke architecture. So there is another way to connect one VPC to other VPC with the help of Transit Gateway. Let me give you one example why AWS or Amazon introduced the Transit Gateway. For example, if I have multiple VPCs, so this is VPC 1, this is VPC 2, this is VPC 3 and VPC 4. For an example, if I want to do the peering with the VPC 1 to VPC 4, also let's say there is a VPC peering between 4 and 3. So this is not necessary like the resources inside the VPC 1 can access the resources inside VPC 3. This is not possible because we need to create VPC peering from VPC 1 to VPC 3. So basically each VPC should be connected to each other. So it will be the mesh connectivity to provide the resource access. So if I want to make the communication possible from each VPC to each other, then it should be the mesh connectivity, right? So in this case, if you see, the peerings are increased. Okay, the peering between the all VPCs are getting increased. So what the transit gateway benefit here? Let me show you here. Let's say I have a transit gateway between the VPC, EGW. In this case, we just need to do the peering with the transit gateway. So VPC1 will have the peering with the transit gateway. Similarly, VPC2 will have peering with the transit gateway. Likewise, for all the VPC. So in this case, we just need to do the peering. For the 4 VPCs, there will be the 4 peer. So 4 peering is enough to have a communication with the other VPCs. So that's why the transit gateway introduced, and it is very helpful to avoid the multiple peering connection. Also, there will be the routing table of this transit gateway, which will decide the resource communication. Like if resources in a VPC1 can have the access to VPC2, but it will not have the access to VPC4. So that can be controlled from the transit gateway routing table. I hope you understand so far. Let's move ahead. Customer gateway, CGW. CGW in AWS Transit Gateway presents the physical or software appliance on the customer's on-premises network, acting as the endpoint for a site-to-site VPN connection to a central regional hub. It requires a public IP address and BGP ASN, and it connects securely to the transit gateway, facilitating hybrid connectivity across AWS accounts and VPCs. Okay, let me explain this topic. So CGW, generally the router or the edge device on the on-premise data center. Usually we use this CGW to establish the connectivity between CGW and our AWS resources. So transit gateway is the entry point for the data center. So there is a VPN connectivity between transit gateway and the CGW, or we can use the direct connect. This is the dedicated WAN connectivity which we get it from the ISP, and it will be the more secure like IPsec, and we can form the connectivity between transit gateway and the CGW. So basically this kind of setup we use for the hybrid infrastructure. For an example, few customers want to keep their sensitive data still in their control, so they keep their servers on the data center. But some services they need temporary basis or less priority, they host on the AWS Infra. So whatever the services they require from the AWS, they can get it from the CGW connectivity. Like as said, with the IPsec and direct connect, we can establish the connectivity between data center and the AWS account with the help of transit gateway. Virtual private gateway. In AWS term, we call it VGW. VGW is the Amazon side endpoint for secure hybrid network connections, facilitating site-to-site VPN or direct connect between an Amazon VPC and on-prem networks. Similar to transit gateway, we can form a connectivity between VGW and the on-premise CGW. Majorly it's a router or the firewall on the edge of the on-premise data center. It enables encrypted communication over the internet or private dedicated links, allowing VPC to access private resources. It does the same job like the transit gateway, but transit gateway is a more flexible that can connect multiple things like VPC, on-premise data centers as well. Similarly, VGW, it's a virtual gateway on the AWS. We can say it's a edge component on the VPC which connects to the router on the data center, physical data center. So there will be the two types of connectivity we can establish between VGW and the data center. One is the IPsec VPN over the internet, and other one is a direct connect. Direct connect is the dedicated WAN connectivity, and both the connectivity provides the encrypted communication and allow to access the private resources. So friends, now we are on the final page of this PPT. In this high level diagram, I have mentioned all the AWS networking services which we have discussed in this video. It will help us to understand the placement of these services in AWS infra setup. Also, in upcoming videos, we will discuss each service in detail with lab example. I hope you found this video informative. Thank you for watching it, and don't forget to subscribe the channel. Thank you again. Goodbye. Take care.